with the idea of passing from numerical index to a fuzzy index, and now from fuzzy index to something different. And also, it could be useful to try to look for what is done in other research areas, for example, in natural language processing, also in philosophy, that Sergio told me about the conversational maxim. But if you read these kind of things, you realize that are maxim of common sense. And obviously, when you are designing a fuzzy system, if you keep these things in your head, you are going to get a better model, or with a better relation with interpretability and this. And finally, some comments about the main discussion about are the fuzzy systems really interpretable or not. If you compare with the technique that if you really black boxes, you are saying that they are really interpretable, because you can say, at least you can say the model in different abstraction levels, and you can go to more or less detail depending on what you are looking for. And in that sense, you can analyze this, the system behavior from the reading of the rule base. But again, the same idea that explaining the system behavior is not so easy. There are some works trying to see if it's possible to explain the output of the inference. People is working, generating in automatic way textual summaries. For example, how to try to explain the behavior of one people with natural language expression. And also there are works that are trying to see if you use also always rules with only two inputs, you can represent the rule base in a table or even in a two-dimensional space, and you can try to graphically understand the system behavior. But this is also a big constant if you have to work only with two inputs. It's difficult to understand. And finally, you need to define an interpretability index, because you are going to use it in the fuzzy modeling process, also in optimization process, and especially in multi-objective problems, where they are building Pareto front with a really simple interpretability. They have clear what to measure the accuracy, but not to measure the interpretability. And again, the important thing for them is not the value of interpretability, but the rank. And the idea of defining a fuzzy index that should be easily adaptable to the preference, the user preference, and also to the problem context. And what I'm doing just now is trying to see if I can group the answer of the different people from the poll in order to discover some groups of the user, and try to see if there are some criteria that are more or less basic or key for this group of people, and you can define a kind of a prototype index or a prototype interpretability measure for this different group of people. In the sense that when you go to a problem and you are looking for an interpretability index, you want something that measures the interpretability according to your own experiment, according to your preference. Then this kind of is like to have a catalog with a set of different prototypes. Maybe some of them could fit with your preference for the prototype. As conclusion, I think I've already said more of the things. The area of there are a lot of work in theoretical aspects regarding what constants to apply to the model, but there is not a universal index yet. And again, the idea to pass from computable number to computable word in order to get something more complex and more useful. And the importance of making this kind of experimental analysis in order to really understand what people is doing. Because usually when an engineer is defining or designing something, is applying his own concept, his own reasoning in the system, but is losing what the other people is trying to understand. If you want that your model is easily understandable by other people, you need to know how these other people is analyzing the model. That's all. Thanks for coming.
Questions, comments, thoughts?
I have a few questions. When you define this model for a fuzzy index, how how did you validate the model?
The model of the hierarchical fuzzy system that I built, this was one of the discussion that I was at the beginning. It was I want to build a fuzzy system to measure the interpretability of a fuzzy system. And can you measure the interpretability of the fuzzy system that you have made at the beginning? How to validate, how to know if this model is good or not. In my opinion, after thinking on that, the idea was making the poll and trying to make the comparison. This is the result that my model is giving, and try to see if it's or not according to what people think about it. I don't know. Maybe at the beginning, the model depends on some parameters, and you can try to adjust these parameters in order to move the result of the interpretability. If you consider, for example, the number of rules, you put some partition to define the number of rules. Depending on how you define this partition, you can consider that 3 is small or not, or 10 is more or less small, more or less big. And after trying to apply a lot of tests in order to see maybe the sensibility of the model with the parameters, it was really difficult, and I realized that the hierarchical structure was making a bias on the result. Even modifying the fuzzy partition wasn't so important like the global structure for obtaining the interpretability. And that's why, because at the beginning, my idea was, why not? I can try to make a slight modification in this global schema in order to get different interpretability measures that could be in the line of the different distributions. It's possible to modify the hierarchical fuzzy system and to get the answer of user 1, the answer of user 2, the answer of user 3. And after making a lot of experiments, I wasn't able to do that. It was, I make a modification, I get higher interpretability values, lower interpretability values, but the global ranking was more or less always the same. It was a slightly different model.
This is maybe one answer to your own question. Why your own interpretation voting on those rules was different from your fuzzy index? Because the model was not validated, not yet validated. One different thing is, I recall that in the late 70s, early 80s, I think it was in the conference in Obama, one time, Sati, he gave us a united talk on decisions making, and he used pairwise comparison, which are much less difficult than ranking a whole bunch of rules. Maybe it would help you to go back to those old papers. I think even Claudia and Celia went further on that, and a Russian guy also went on that line. And then suddenly they stopped this kind of research. And it was very interesting because he could make very complicated decisions on picking up, let's say, how to buy a house, and all the parameters, just making pairwise comparisons for the user, which are much less difficult than comparing 10 different things at the same time. But that might help to continue this line of research. One more aspect that is important to mention here. It sounds funny, but I think it's true. Interpretability requires the willingness to interpret. And I'm saying that because usually, not only this talk, but in many talks, I hear that fuzzy systems are, of course, interpretable. Neural networks are black boxes. That's a lie. Already in the thesis work of Nanitas and Nara and Nanitas, he showed how to look inside the neurons and see what was going on in our interpretation, which maybe expresses a set of past rules. So this is total equivalence. The equals 2000, Tema and myself extended that to a whole family of neural networks, which are no longer black boxes. You can clearly say what's happening in the neuron. So that's what it requires the willingness to interpret and avoid logos. So, neural networks, black boxes. Fuzzy system, interpretability. Those